Hi, this is Cyprien from FE4, and in today's video tutorial I'll show you how to simulate a simple 2D plate in Salome-Meca using code-aster to do the solving. So it's a pretty basic example, but you'll see it's not necessarily as simple as you may think if you're using Salome-Meca. But let's go forward and start our project. So now I just open Aster Study, and let's create a new document. So now I have my new project, and the first thing I have to do is to create the geometry. So let's switch to the geometry module, in which you will find all the tools to create your 2D plate. So to create the 2D plate, you have to start from creating the points, then linking the points with edges, and then linking the edges with a surface. So let's set up the view. So I want my axis to be X and Y. Let's drag it like that, and let's open the walkthrough so I can see that. And the first thing is to create points. So click on create a point, and you can just enter manually the coordinates of the points. So I'll create a plate with a hole here. So that's like a classic example, and I'll give a name to the points so it's more easy to understand what happens. So for the first points, it will be 10. Okay, apply, and you see my point appear here. 100. So for this one, 100, and this will be A, and let's call it H, for example, H. Okay, 1 point here. Now the other side of the plate will be 150. Okay, so, and let's call it G. Apply. And now I need a point here, so it will be 150, 0. Okay, let's call it let's call it F. Okay, you can call the point as you want anyway. You can even let the name here, but I like to give a name to the points. Okay, 10, and let's call the point B. Okay, apply and close. Now I got my points, and the only thing I need to do is to create some edge. So let's create a line. Sorry, I don't know what I did. Okay, I think I extended this window. Okay, so I selected the point B, which is this one, B. So let's select this point here, BF, and let's call this line BF, so it's more clear. And the edge here now was created. Now it automatically select the point F, and you have to select this point here, which is okay, click. Okay, this is the point J, so FJ. Again, it selects J, so let's select this point H, so I have GH, apply, and last one is H, and this is A, right? HA, okay. Apply and close. Now I want to create a small arc here. So to do that, I'll have to use the function here called arc, and switch the construction method to the second one, which means that I'll have to select the center point, and you could create the center point here, 0, 0, 0, but you can directly select it from the walkthrough here. And now I have to select the point where it starts, so let's say A, and the point B, and you see the arc is now traced. apply and close. Now I got my arc. Okay, now I got the edges of my plate, but now I need to build the face. So to do that, go in the tab here, new entity, and you have something called build, and you can build a face like that. Let's give it a name, call it quarter. Okay, sorry about that. Quarter plate. Quarter plate. Okay. My God. Okay. Apply and close. Oh, okay. Yeah, I forgot to select. So I can directly select here. So it's faster, and you have to press to keep Control pressed. So you want to select everything. Apply and close. And now I got my plate. So you see that automatically when you create this, all the other edges, lines and points are automatically hidden. So you have only this plate. Now what you have to do, and this is very important step that you may forget at the beginning, is to create some groups. So the groups are basically something you will use later on to assign a boundary condition to an edge, for example. In Salome-Meca, you cannot say directly, you cannot select directly the geometry like that and say, oh, I want to apply on this boundary here. You have to create a group which is called like bottom, and then say, oh, I apply the boundary condition to the bottom. So it works like that. So go in new entity group, create a group, and select here, select edge group. The main shape should be the quarter plate, and then okay, maybe I reselect. I have to activate it like that. And now, okay, now I selected this, add it, and you have the number of this edge which appears in this window here. And let's give it a name so it's better. Let's call it bottom. Apply. And now it should appear. Okay, I should open that. Okay, and now you have the group available here, bottom. So let's do the same thing for the top. Select the top edge, add, apply. Okay, got it. And let's do the same thing for the left, because I'll have boundary conditions to all those edges. Left, add, apply. And now I want also to create groups for points, the points A and B, so it's faster afterwards to get the result at those points, for example. So here you have to change the shape type, and now you see those 2 points, and click here. So this is the point A, if I remember well, so let's call it A, apply. And this, yeah, this is the point B, add, apply and close. Okay, so now I got 5 groups. So I will use those groups later on to create mesh groups, which will be used, you'll see, to assign boundary condition and all those things. And you need to have those geometry groups created first before you create the geometry and before you mesh, otherwise you'll have to do all over again. So that's why you need to do that first. Okay, so I created this. Let's go now in the mesh module. Okay, let's create the mesh of hot plate. So you have a button here, I think it's the first one, called create mesh. So click on that, and here you have to select the geometry. So here I have to activate again my plate, and okay, it's selected. Well, I can give it a name, so let's call it also quarter plate. Okay, and this is a 2D type of model, so select mesh type 2D, an algorithm will be using this measure. So you have possibility to use several types of meshing. So I'll let you discover all those options, or maybe I'll do another video about that. And now that you have this, you have to put some hypothesis on the mesh, basically to define the size of the mesh. So click here and add some 2D parameters. So here basically you can set up the fineness. So let's choose fine, for example, or let's just use moderate for this. Anyway, this is a tutorial. And let's choose second order. Okay. And I have done that. So click and apply, close, and now you see that I have mesh here that has just appeared. So now that I have that, basically what I have to do is to compute this mesh. So you can either click on the mesh here on the tree and right click, and you have an option compute, or you can get it from here from the bar. Okay, so let's click here on the button and let's compute the mesh. Okay, that's done. So you see that you have 118 triangles. Okay, so again, that's a very coarse mesh. You won't probably get very accurate results with that, but anyway, that's just to show you the process. So, and now there's something more to do. Once you computed the mesh set, you have also to create groups for this mesh set, so you're able to assign the boundary conditions. But the good news is that you can create those groups for the mesh automatically using the group from the geometry that you created. So you have to go here in the tab mesh, and you have an option create groups from geometry. So click that, select the quarter plate from the mesh, and geometry. So you see you have elements and you have nodes. So you have basically to separate the selection. So you have to select those 3 bottom, top, left, which are edges, and display them here in the geometry. And here, sorry, I shouldn't have clicked. Okay, so here I have A and B, which are nodes. So once you selected that and that, click on apply and close, and you'll see that in the mesh here you'll have group of nodes and group of edges, which will be automatically created. So that's very important to assign the boundary conditions after that. Now you still have one last thing to do, which is also important, is to actually export your mesh. So you need to create a file in which you will save your mesh, so code-aster after that will be able to read it and use it in the aster study. So to do that, yeah, click here on quarter plate, right click, and you have the function export, and export it under a met file. And you can give it a name, so let's call it quarter plate 2, because I already did one example before. Yeah, so I won't confuse it. Okay, save, and that's it. Okay, so now I created the mesh. Next step is basically to create the study and to assign boundary condition and all of that. So to do that, switch to the aster study module. And here you have to start by creating a new stage. So right click, add a stage, and you see that the buttons here are now activated. So you have basically to go from the beginning to the end, selecting all the options you need. So the first time you do that, you probably don't know, but basically the process every time is more or less the same, but maybe sometime you will need to add something more. So the first thing to do basically is to read the mesh. So click on read the mesh, and here select your quarter plate. And once you get it here, don't forget to mention the file format, which is in met format. Okay, and now it's added here, and you see that this function actually can be written like that. So code-aster before 2017 wasn't using aster study. It was using directly a text file in which all the functions were listed, and then it was simply, you know, running this text file function one function by after that. So the problem of this that way before was that you had to know all those functions, and here in aster study it's all written, so it's more straightforward than before. So now that you read the mesh, there's something more to do, because this is a 2D model, 2D plate, so you have to specify direction of these mesh sets, otherwise the solver will not be able to calculate it. So to do this, you have to click on modify a mesh, and here there's also something very important to do. Don't forget to do that. You have to change the name, and you have to call it with the same name than the first read a mesh command. If you let the 0 here, you'll get a problem when you do the computation, so that's very important. I didn't know that, and I discovered it that you have to do like that. So probably if some developer is watching this video, then I think you should do something. Okay, anyway, so now you open this function, modify a mesh, and what you have to do is add this function orientation po 2D. So po in French means skin, so basically it's the function to orient the 2D skin. So that's how you can understand it. And here, click here, edit, and you have to define a group of elements which will help you to define actually the direction of this. So edit, and here you'll find all the elements, 1D element sets that you created before, and you can select the top one, for example, and this will define the orientation of this. Click on OK, click on OK, OK again, and you have it. So that's the first step, the mesh. Second step, model definition. So you have to assign a finite element model. So you have to basically to tell that you will do mechanical linear static analysis. So let's select the finite element model, and here you have, okay, so all the mesh elements, and here we are using mechanic, and the modelization is the way we actually model that. So there are a lot of selection, as you can see. We can model it as a 3D, as a 2D, as a 1D element. Here we have a 2D plane, maybe I'm saying, so we have a plane strain model. So for this type of model, the modelization is called C-plan, so you have to select this one. Okay, let's just check again to see what this C-plan mean. So I will not, I'm sure I'm not telling you bullshit. So you know, when you don't understand something, just have the Google reflex. So go on Google and just search for the name of the function, and you'll immediately find some kind of file like that detailing what it means. So C-plan, so you have C-plan and you have D-plan and you have axis. So axis is axis symmetric, D-plan is a plane deformation, so I think it's plane strain actually. It shouldn't be written deformations, and here C-plan is plane stress, right? Plane constraints, plane stress. I think there's a bit of problem in the translation of this document, but anyway, it's plane stress. So so this is the kind of modeling that we will use for this plane stress. Okay, come back to Salome-Meca. So I selected that, click on OK. Here I have to select my mesh. Okay, and I got it. Now, next step is to define your material. So you have two steps. First, you need to define the material, and then you need to assign it to your model. So click on define. Let's give it a name. So steel, for example. And this is a linear isotropic material, so basically only two coefficients to define. If you don't have the gravity, of course, otherwise you'll need also to define a third coefficient, which is the density, but here we don't need that. Okay, got it. Now let's assign this material to our model. Field mat model. Okay, let's select the model and assign the material everywhere. Okay, done. Now next step is to assign the boundary conditions and the load. So what I'll do is that I'll fix the plate on this left boundary. I'll fix it so it cannot move in the x direction, and on this boundary I'll fix it so it cannot move in y direction, and on this edge I'll apply a pressure of direction -100, so it will go in this direction. So let's do that. Boundary condition loads, assign mechanical load. So we'll have three boundary conditions to assign: 1, 2, and 3. So let's define first on the left and on the bottom. So those are enforced DOF type of boundary conditions. So let's add those two. First one, edit, and I will apply it on a group of elements. So that's where it's useful to have created those groups. If you didn't create those groups, then you'll have a lot of difficulty to select that. And here fix the degree of freedom in x direction. Okay, now I got my first boundary. Now do the same for the bottom. Group of elements, bottom. Okay, and this time I'm fixing the y direction. Okay, now I want to assign a pressure, so let's take a look. Where is the pressure? Okay, pressure. Okay, you have pressure sigma, pressure rep, and pressure EPSI. So I think the one I want to assign is pressure rep. But again, if you want some details, just search on Google and see exactly what each of them means, so you don't make a mistake. Now select the group of elements from the top, and let's assign a pressure. And if I'm correct, if I assign -100, if I assign -100, it will go in the, okay, it will -100. I think this is the right direction. Okay, and that's it. So I assign my load. So under one comment, you see that I have my 3 boundary condition defined, and the function, textual function, is this. Okay, now what's the next step? Next step is to, okay, pre-analysis. Okay, I don't need that. Analysis. Okay, I need to define static mechanical analysis, and let's call it Rusu. Okay, Rusu, and okay, and let's define the load here. assign the load to the model, and I think that's all I need. Oh, yeah, I need to select also that structural element. No, matter of field. Okay, yeah, matter of field, the model, and the load. Okay. Okay, and now next step is if we want additional types of results. So if I don't define post-processing results, then I will get only displacement. I won't get the stress, for example, but here I want the stress also. So let's select this calc champ. So champ means field in French. So yeah, very intuitive, I know. Okay, Rusu mechanic. And here in this list I need to select the type of results I want. So contrainte means stress in French, so if I want stresses I have to select this type of result, and here again you have to select the right type of stresses. So I think those ending in GA means ghost points, NO means node, EL means element. So here you have stress, nodal, EU. I know what is EU. So if you want to know more detail, again, search on Google and you'll find a file where you will have all those details. Okay, so for this tutorial, let's add this sigma LNO, and let's add also sigma LGA. So element ghost points, element nodes. So basically I'll get the stress of the element at the nodes. Okay, I think. And let's also add something here. Okay, sig LNO. Okay. And now last step is to define the output results. So this last function is important. If you don't do it correctly, you won't display the results afterwards. So select your result file. Oh, okay, so here what I'll do is that I will create a new result file to be sure that so you have to go in this tab, and let's enter the name. So you can enter any name, whatever you want in this, and you have to give it the extension. So I'll call it result2. You have to give it the extension med, MED. So med is the mesh format, so if you add a R is result mesh basically. So that's the kind of extension you have to add. Click on save, and here tell it give it the format. And last thing to do, important, is to assign the results. So you have to assign the result object Salome-Meca static. Okay. Okay, and basically after doing all of that, you should you will get your analysis set up. So you have to compute all that, send the result to solver. But first, let me show you, if you want to export the command file and see how it looks actually. So you can right click and let's wait a bit. You should be able to create a command file. Okay, let's call it stage1com. Okay, let's give this name. And now I'm saving this. So if I open that, if I open this command file, let's see what I get. You know why I'm not seeing the content. don't know why it's kind of slow. Okay, here, Salome exercise. Okay, so this is the command file, and you get something like that. So actually, all the steps we just did in Aster study, everything is resumed in one command file. So if you have to do all of that again, you can simply copy paste this command file and run the simulation, and you don't have to go through all those steps. So if you want, for example, to change the value of the force, just go here, change the value, and run. You cannot run it like that directly with Aster study. You'll have to use ASTK, which is another module that I didn't talk about in this video, but I'll probably do another video later about ASTK to show you how to do that. Okay, let's come back to the video. Okay, let's come back. Now, how do you run that? How do you get those results? Go here in history view, and okay, and here add the stage. Click on run. Okay, I should save the study because I forgot to save it. Save that. Okay, here at this step, if this window, if you click here and nothing happens, or this window it doesn't run, basically, there are several problems that you may have done. So let me tell you quickly, because I know a lot of people have this problem. The first problem is that here in your calendar, maybe you have some foreign name. So for me it was written in Chinese, so basically there is some kind of conflict with the timestamp and it doesn't recognize the characters. So if you are using another language, like, I don't know, Polish, or a language with strange, signs and letters, you will have some kind of problem. So what you have to do is go in the settings of your Ubuntu system, and here you have language support, and here regional format, and make sure that you have English United States here, and then click on apply system wide, and restart your system, or you restart your code-aster, and then it should work again. And there is a second problem, which is not everyone has that, but if you have some spaces inside your path, inside your file. So if you save your file in a directory where there is a spaces in between the names, you will also get an error. So don't do that. So add some letters or something, but don't add spaces inside the path. Okay. And there is a third problem eventually. If you still getting red and you're getting 127, it's maybe because you didn't install the lib open blast library. So I did another video to explain that, so I won't go that in detail in this video. Okay, so I got the results. So let's take a look at the message. And in this file you'll get all the details about what the solver actually did in details. So here everything will seem okay, no warnings, so that's nice. So let's come back to the case you hear, and there is a second tab here, data file, where you have your results file. So here there are two files, your mesh and your results file, and they are linked to your model. So to see the result, you have to right click here and click on open in Paravis, which is the post-processing of Salome-Meca, and then wait a bit and it should open those results. Okay, so now you get the results here, and if you want to display that, go on this menu and you see surface. You can display with the edges, and you get those results. So I will do another video a bit more complete about the post-processing and how to actually look at the stress results and extract the data from the nodes, for example. So because this video is becoming a bit long, so you just have to, I will probably put the link to the second video in the description, so go in the description if you want to see that and click, and you will have the details about how to visualize the stress and the results into Paravis. Okay, so I hope this video was helpful for you. And if you want to know more about FEA, code-aster, or even much more about theory, about all things, you're welcome to go into my blog, feaforall.com. You can subscribe to the newsletter. You'll receive a lot of interesting articles that I'm writing. I'm trying to make all of that easy for anyone to understand. And I hope that those videos and everything I create is useful for you. And if it is, don't forget to let a comment on the video, tell it to me, or send me an email, or anyway, or help me to share those videos with your colleagues. That's always a pleasure to see that someone is gaining and is learning from what I'm doing. So thank you so much for watching, and see you probably in the next video.